anyway, this is one of my favorite topics, always has been. So I know that this one usually gets a big crowd. So I see there's a bunch of folks in the participants list. So just to remind you, if you have questions, you can put them into, would you like them to use Q&A or chat? Which one would you prefer?
Chat is always the easiest because that's what I can see and you can see.
Yep.
Q&A, sometimes other people can't see the Q&A, but if you put into chat and you send your question to all panelists and attendees, then everybody can see your question.
Yep. Excellent. All right. Anything else before we just dive right in?
No, I
We all
think we're
good?
good.
All right, great. Okay, so just to remind, at any point, put your questions in the chat. If you happen to accidentally hit Q&A, that's fine, but try to put it in the chat if you can. And I will get to questions at the end. I learned a few months ago not to stop during this program and do questions because, usually everyone has a lot of questions and we may only get through half the program. So we want to make sure we actually get to the end. So I'll save answering the questions to the end, but you can put your questions in at any point. So let us dive in. You're not here to see me, you're here to see some cool pictures. So let me share my screen. Oops. We need to put me on as a co-host so I
Here
can
I
share my
come. Here
screen.
I
Oh, that's
come.
okay. I'll blather on until you do that. Oh, wait, you're so fast. So there it is. Isn't technology awesome? It actually, when it works, it's great. All right, so here we go. This one's called Roving the Red Planet. It is one of my favorite programs, like I said, because it is different just about every time I do it. There's something new. There's something interesting about Mars that we learn that I have to share. So let's just dive right into what we know about Mars. So let's just set the groundwork for the red planet. So Mars is one of the first four planets from the sun. It is the fourth. And it is about half the size of Earth, a little bit more than half the size of Earth. But you can see it in comparison to the other planets that are closest to the sun. We call those the rocky planets. It's not that they're entirely made of rock, but the surface is made of rock. Presumably, there's something there for you to stand on. I mean, we're not actually going to go to Mars and stand on it, not anytime soon. But that is kind of the gist of it. There is rock there on the surface of Mars. Now, I mentioned that Mars is about half the diameter of Earth. By comparison, our moon is about half the diameter of Mars, just by coincidence. To give you a sense of the surface area, because diameter tells you one thing, what is it like as a round ball? If you take all the landmass of Earth that's above water, so above the water line, that's about equal to the landmass, the total landmass of Mars. So there's a lot there. You think of all the continents and islands and things of Earth above water. There's a lot there. There's a lot for us to explore. So if people ask, "Oh, we're sending another spacecraft to Mars? Why haven't we learned everything yet?" Oh my goodness, no. So we have not learned everything yet. Now, if you want to know what the gravity of Mars is like, well, if you weigh 100 pounds on Earth, you're going to weigh about 38 pounds on Mars. Instant weight loss. Although it's not actually loss of weight, it's not loss of mass, it's loss of weight. What weight is essentially the pull of gravity of the mass on whatever mass is there. So you can be made of the same amount of stuff, and you can go to different places in the solar system, and depending on the pull of gravity at that place, you might weigh more or less. For example, if you were to go to Jupiter, you would weigh about 2.5 times more than you do here on Earth. But Mars is about 1/3 the weight that you've got here on Earth. But like I said, it's not actual mass loss. When you come back to Earth, you're going to weigh the same. So, all right. Mars, I mentioned, is the fourth planet from the sun. It's about 1.5 times farther out from the sun as Earth is. So a little less than 150 million miles on average from the sun. That means is we definitely, if we need to, we can send spacecraft using solar panels for energy. Now, the last two rovers to go to Mars did not or do not use solar energy for power. They use essentially the decay of radioactive plutonium to generate electricity. A massive, about 100 watts of electricity total. But if we need to, we can send spacecraft using solar energy, and we have done that in the past. So we have a variety of options available to us to generate energy if we're sending something to Mars. Now, having that planet be 1.5 times farther out, it means the sun is only about 2/3 of the diameter in the sky as it is here on Earth, so it'd be a little smaller. Also, Mars would have a lower temperature because it's farther out from the sun. One thing, it's a common, I hear it commonly where people look at the color of Mars. We call it the red planet. And what do we think of? If I just say the word red, what temperature do you think of? I bet you think of a hot temperature. Well, that's because on your faucet handles at home, you've got a red dot for hot and a blue dot for cold. But the red color of Mars is not due to its temperature. It's due to basically a type of iron that's in the dust, and so we get that kind of reddish, rusty color. But the temperature, the actual temperature range of Mars, is not hot. It does not match that red dot that's on your faucet. It is at its warmest, about 86 degrees Fahrenheit or so at the equator. At its coldest, southern hemisphere Mars winter, look at that temperature, 284 degrees below zero. If you thought Chicago got cold, no. Mars is definitely not the place to be. So we've got the planet is farther from the sun, the temperature is lower. Why does this happen? Why what is another reason why we've got such a huge temperature range on Mars? Well, the atmosphere is very thin, only about 1% of what we have here on Earth. It's not no atmosphere. It's not that there's no air there. There is a little bit, but it is pretty thin. About, I think I mentioned about 1%, which you've got here at the surface of the Earth. Let's put that another way. In order to get the equivalent air pressure on Mars, here on Earth, you have to go 100,000 feet above the surface of the Earth and measure the air pressure there. That's 20 miles up. That's a long way up. And so the air pressure of Mars is very thin. There's not much air there to move the heat around. And so you get these temperatures that are low, but you also get these wild swings of temperatures, even in one day. I just, right before we started, I took a screenshot of a portion of the NASA Mars website. And this was the latest weather report that we've got from the Perseverance Rover. So look at that, a high of, oh gosh, wow, look at the equivalent for July 8th. That was a high of -17 and a low of 110 degrees below zero. Or July 5th, a high of -9 and a low of 117 degrees below zero. Again, there's just not that much air to move the heat around and trap the heat. And so that's why you get these low temperatures and these wild swings of high temperature to low temperature during the day. You're not going to get this kind of temperature swing here on Earth. Our air is just a lot thicker, and we can move that heat around a bit more. Mars does have 2 moons, but take a look at their sizes. If you stuck these moons in Chicago, you'd have room left over. So they're tiny. So the total size of the 2 moons is just a bare fraction of the size of our moon. Our moon is gigantic compared to these two. All right, let's take a look at the planet. So this is a basically a true color view. I said we call Mars the red planet, but if you look around your house, if you've got something red, say, or you can look out a window and you can see a stop sign, or if you're at the library and you see an exit sign, something like that, then you know that we go, wait a minute, that's red. This doesn't look all that red. I mentioned that the surface of Mars contains a lot of iron and iron-bearing minerals in the dust. And if you grind up that iron-bearing mineral really, really, really tiny, really finely, you get this sort of butterscotchy color, but you also get gray. You get a lighter pink color. There's all sorts of color ranges on the surface of Mars. Also, if you take a look at certain parts of the planet, you will see something that's familiar to you. I've got a glass of water here because you know, I talk a lot during my programs. You probably know that by now if you've been to one of my programs. Filling an hour is not a problem. But if you freeze this water that's in my glass, well, you'll get the same stuff that's in your freezer, and you get the same stuff on Mars. There is a lot of frozen water on Mars. Mars, and following that water, finding out where is that frozen water. Was there any liquid water on Mars in the past? Following that water has been a key part of NASA's exploration of Mars for the last 25 years. And so I want to show you some examples of where we currently find, I'll say, water ice on Mars, and where we think the liquid water may have existed in the past. And what do these stories tell us? Now, I did not misspeak. Water is not just the stuff that comes out of your faucet. We use that term as the stuff that comes out of the faucet, but water is H2O, two atoms hydrogen, one oxygen. That is water. Solid water is what we call water ice. Liquid water is the stuff that comes out of your faucet. Water vapor is the stuff that comes out of your tea kettle. So we have all of that here on Earth. You can find some of it, at least, on Mars. Here is what I think is just one of the coolest new pictures that has come from Mars. This is not a computer simulated picture. This is not a picture from Arizona looking up at the sky. This is a picture from the Curiosity rover looking up at some rocks nearby where it is located in Gale Crater on Mars, and it's looking up at the sky at wispy water ice clouds. We see ice in many places on Mars. Just look at that picture. It just looks like you're standing there, right? I love that picture. Anyway, this is a series of three different pictures. These are also water ice clouds seen over Gale Crater. You're not going to get puffy thunderstorm clouds or anything like that. You're mostly going to see some of these wispy clouds if you see them. Sometimes you see uh, what looks like a little bit more like those stratus type clouds that we see here on Earth, but these are still kind of those wispy ones. This is clouds near sunset at Gale Crater. So that's why they look like they disappear, because the sky is getting darker as the sun is going down at Gale Crater. Now, if you are watching me on a screen where you can actually see color, you may not see this very well on your phone if you're watching it on your phone. If you're watching maybe on a larger screen, a laptop screen or something, and if you happen to notice color, if you see that sort of pinkish color or maybe some blue right in through here, those colors are real. We call this type of cloud a noctilucent cloud. We see them on Earth too. I've never seen them here at our latitude, but you can see them farther north. You see them, these clouds are at an extremely high altitude. The color is due to ice crystals of these that make up these clouds being nearly all the same size, and they are bending light or refracting light from the sun, making that blue and pink color. Again, we see those types of clouds here on Earth, again, higher altitude. But it's neat to see those colors being real and seeing some of the similar type of phenomenon. The sun has gone down in this location, but we still get some sunlight at the very high altitudes lighting up these clouds. So that's water ice in the air on Mars. How about water ice on the ground, or in the ground in this case? So periodically, you get stuff from space smashing into Mars and makes craters. And sometimes those things from space smashing into Mars excavate craters and ice splashes out. It means there was water ice under the surface, and it was exposed by the making of this crater. So this particular crater formed about, close to about 13 years ago. and the ice splashed out. And when we saw that crater a few months later, and these were taken from orbit, we saw the crater a few months later, you don't really see too much of the ice. What happened in the intervening few months is it vaporized. It was exposed, the dirt, the dust that was covering it up was moved out of the way by the making of the crater. And so this ice no longer had the ability to just kind of sit there. It vaporized, it turned into a gas. Mars's atmosphere just isn't thick enough to keep the ice or keep lots of this ice solid. So if you expose it, it will turn to a gas. We see this as well in this set of pictures taken from the Mars Phoenix craft, which landed, I believe it was also 2008. And if you look in this trench right here, so this is a trench that that Phoenix scooped in the dust. So they put the scoop down in the dust and scraped it, and it dug down about 2 inches. And if you look at it in this in the left hand side of this picture, you can see little ice chips. Those are water ice chips. This water ice was about 2 inches below the surface. That's all they needed to do was to dig down a little and scrape. And there it is. And if you take a look 4 days later, it's no longer there. It vaporized. So it's pretty neat that we know Mars has a vast amount of water ice under the surface. Um, how much? Like a lake's worth, like several lakes worth of ice. Put it another way, if you melt all the ice that's under the surface of Mars, and how much of Mars would you cover? It'd be about 115 feet deep of water all over the surface if you melted all the ice that we know exists under the surface of Mars. That's a lot of water ice, like many lakes worth. But okay, fine. Water ice is under the surface. Water ice is in the clouds. What about liquid? Everyone wants to know, is there liquid water on Mars? And the answer is so far, what we have found is no, not currently, not on the surface anyway. But we had started to see intriguing evidence decades ago that liquid water once flowed across the surface of Mars. It was a long time ago. But take a look at this picture. And I don't know about you, I don't have to be a geologist or anything like that to take a look at these squiggly looking patterns and you go, man, that sure looks like a dried up riverbed on Earth. If you think of a picture of a river like the Mississippi River, hey, parts of it look like that, right? So we started seeing this evidence for liquid water, and the more we looked, the more we found. And again, this was literally billions of years ago, but it started giving us more intriguing questions to ask. How was it there? How long was it there for? Where did it go? Um, and then was the water there long enough for life to form? So we started sending rovers to Mars with the 1997 Sojourner rover. It went along with the Pathfinder mission. And a few years after that, in 2004, we had the landing of the Spirit and Opportunity rovers. And where Spirit landed was this place. The crater at the top, the large crater, is called Gusev Crater. It's about the size of the state of Connecticut. So next time you look at a map, just look at Connecticut. Actually, do you one better. Look at a world map and then identify Connecticut on the world map. And you'll be able to see that that's not a huge crater, but it'll put it in perspective as to what size it really is. It's kind of hard to tell with a picture like this. But when scientists look at this picture, they go, "Wow, boy, that sure looks like there was a river leading into that crater. So maybe we should land our rover there." And let's go see if we can find evidence in the rocks that liquid water was ever filling up this crater. And so they landed the rover there and they started studying the rocks. And what did they find? No evidence of water. Well, they then drove the rover up into a few hills that were located sort of near the middle of the crater, not too far from where it landed, and they started studying the rocks there. What did they find there? They found, in many cases, this stuff. This is called silica. Silica, the chemistry term for it is silicon dioxide. And on Earth, in order to get high concentrations of silica, you need water. There's no other way to make that much silica in that small of a spot, or that concentrated of a location, without water. This sample that you're looking at right here from the Spirit rover, when it kind of dug through some dust, this is 90% silica. This is so concentrated, water absolutely must have been involved in concentrating it. In this case, we think that this was a hot spring environment on Mars. And when they tested these rocks, they also include minerals which only form in the presence of water. It is believed that Gusev Crater may have held a lake a long time ago, but it was in the intervening, billion or two or so years, covered over by volcanic dust. One thing I didn't mention was Mars has volcanoes, and they would erupt from time to time and spread dust and ash and stuff around the planet. And so slowly the dust and the ash and the rock and stuff filled up the floor of the crater. And so I had to drive up into the hills in this crater to be able to get to the evidence that liquid water really was here at one point. Here's another set of rocks. This was also taken by Spirit. By the way, this is not a true color picture. Think of this picture like paint by number. I know that those of us of a certain age and older will know what paint by number is or was. So imagine scientists colorizing a picture when all the rocks of a certain type, they just said, okay, we'll color those blue. And that's exactly what they did here. So the rocks are not blue normally, but sometimes NASA and scientists colorize some of these pictures to bring out patterns that if you just leave the picture in its normal everyday how it appears on Mars, you might not see some of the evidence. Well, in this case, Spirit actually went to study some of those rocks, and they named those particular outcrops Comanche. And this outcrop called Comanche contains a mineral that indicates that a past environment was wet and not acidic. What that means is the less acid you have in rock, the possibility is that it's a more favorable environment to life. There is the type of mineral that we're talking about is called carbonate. Carbonate on Earth originates in wet and nearly neutral conditions. But if there's a lot of acid, that will dissolve the carbonate and it won't be there anymore. So in this case, this set of outcrops says that a past Martian environment here may actually have been more favorable to life. The more and more acidic the water is, the more extreme the life needs to be in order to have the ability to survive in that kind of environment. We have the same thing here on Earth. We have types of microbes that can survive in really acidic environments. But if you were to put you or me or normal, regular, everyday type life in that particular environment, we wouldn't survive. So if there were microbes in this area, which we don't know if there were, I'm not saying that there was life here. I'm saying that this environment could have been more favorable to life than just that really hot, acidic hot spring. All right. Where opportunity landed, um, it, among other things, discovered these mineral veins. If you see that lighter colored mineral in the rocks here, now how in the world did that get there? It almost looks like somebody just went and dropped a line of white stuff down there on the ground. Well, these are minerals that are within the rocks, and the rocks contain cracks that filled up with these minerals. The hot water flowed through, the hot minerally water flowed through, and when the water dried up, it left the minerals behind. This particular mineral is called calcium sulfate. And you may know one form of calcium sulfate as plaster of Paris, and another is the mineral gypsum. And if you aren't familiar with gypsum, I know you are, but you may not realize it. So if you have a newer home, so maybe if you have an older home, your walls might be made of plaster. But if you have a newer home and you have drywall on your walls, You ever been knocking a nail in the wall and you absolutely you miss and you knock a hole into your drywall and that you get to that, you break through the paper and you get to that powdery stuff beneath? That's gypsum. So if you have plaster walls or drywall walls, you have a connection to a mineral that we absolutely find on Mars. We find it on Earth here too, but we find it on Mars. Same stuff. It's pretty cool if you think about it. All right. This is Gale Crater, and Gale Crater is where the Curiosity rover is located. And they landed Curiosity in the flat part of the crater because it's just easier to land spacecraft where it's flat. And the goal was drive toward the mountain in the middle called Mount Sharp and study the rocks along the way, study the rocks at the bottom part of the mountain, and keep going and study the rocks in subsequent layers up a little higher. The reason for this: layers at the bottom, presumably, are the oldest. Layers farther up are younger. So you can uh, get a sense of the geologic history of this place by studying the rocks. And you can see what happened over time based on the minerals that are there. Let me give an example. If you find, I should back up, the mineral olivine. You probably have seen it if you've been into a jewelry store. Um, if you know the gemstone peridot, that is a form of olivine. Well, olivine plus water equals clay. We know clay here in Northern Illinois, right? You dig down far enough in your lawn, you're going to strike clay. This area where we live a long, 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 long time ago was covered over in water, an ocean, as a matter of fact. And so if there was olivine here, it was converted to clay. And so if you find olivine on Mars, there was likely no water there. If you find clay on Mars, there was likely water that interacted with that surface right there. So that's kind of some of the stuff that they're looking for. Not just that, but that's some of the stuff they're looking for. All right. When you look at Gale Crater from space, here is Mount Sharp near the middle, and they landed Curiosity in the flat spot. This crater is about 100 miles wide. And if you just kind of notice, you go, oh, wait, looks like a little dried up river right there. And that's exactly right. There was a dried up river that flowed down the side of that crater down into the bottom. The water spread out and pooled, and then we had this pool of liquid water. This was a free-flowing stream. And this probably happened from time to time. It probably periodically happened where the water would flow and the water would dry up and the water would flow and the water would dry up. Well, what is some of the rock that we found in kind of this fanned out area where the water was flowing? Well, the picture on the left shows you an example of that. That is a picture of rounded rocks stuck together on Mars. Picture on the right, rounded rocks stuck together on Earth. The picture on the right is a dried up riverbed in the country of Chile. The picture on the left is a dried up riverbed on Mars in Gale Crater. So again, we know what happens here on Earth. We can apply that information to Mars. And so we can get a sense of what happened there because we go, well, if we get rounded rocks because they get all rounded because of the water and the friction and all of that, well, that's probably what happened on Mars. Pretty neat. And this doesn't look like much, but this, I think, is definitely one of my favorite pictures of Mars, if not maybe my top picture, maybe like 1 and 1A. This is something we all can relate to, especially this year when the weather's been a little screwy and a lot screwy. And from time to time, we've had some periods of some dry weather, right? There were some periods several months ago. Well, in the past few months, we have not been getting the amount of rainfall that we needed. And there was a time, couple weeks, 2, 3 weeks, we didn't get any rain. If you happen to have been walking through, say, a forest preserve or a park, you might have seen a dried up mud puddle. That's what this is. This is a dried up mud puddle on Mars. Except this dried up mud puddle is over 1 billion years old. But it looks like it was dried up, a few days ago. But this, again, is something we definitely can relate to. Well, the rovers, ever since Spirit and Opportunity, and including Curiosity and also Perseverance, the latest rover, they have the ability to drill into rocks. I want to show you all of the drill holes that Curiosity has done. These are 29 different drill holes. And the reason they do that is so they can get down to some pristine rock underneath. The rock on the outside, you can kind of get a sense of what's going on there, but it's been sandblasted and irradiated and all that. So you want to get to the stuff underneath that hasn't been sandblasted or quite as irradiated. But take a look. I love this set of pictures, because the different colors of the dust that you see are from the interior of the rock. And depending on the color, that tells you the different kinds of minerals and fluids that passed through these rocks. Drilling is important to get at these pristine samples. But I just love the color palette. You've got everything from almost blue to almost bright red, or at least red orange, and everything in between, gray and stuff like that. So again, this is just a really neat way to see these different samples, and to see the range of the types of information that we're getting. I don't even have to tell you what this stuff is. To be honest, I don't know what all those minerals are. It doesn't matter. The point is, this is why we send rovers with drills, because we can get at a bunch of information that might be lost to us if we're just studying the outsides of rocks. All right. I mentioned Perseverance. Perseverance is the latest rover to land in February of this year, and it is the size of a small car. It weighs even more than Curiosity. So Curiosity is the rover on the left. That says MSL, Mars Science Laboratory. That was the original name of Curiosity. Mars 2020 was the original name of Perseverance. By the way, if you're ever looking at a picture of the rovers or an artist's rendition, these are both artist's renditions. If you're ever looking at the pictures and you're not sure which one is which, just look at the wheels. They look almost like twins. They basically are, except for the science instruments are different. But just look at the wheels. The wheels of Curiosity have kind of this angled pattern on them, and the wheels are a little wider. The wheels of Perseverance are a little bit not as wide, and the tread is a little straighter. We had to learn really quickly some problems that we had with Curiosity's wheels. They got holes and punctures in the metal that forms those wheels. There's no air in the wheels. They're not like tires, but the metal can puncture. And so we did see that as the rover drove over really sharp rocks, they got some holes, and so they wanted to make Perseverance's wheels last a little longer and work a little better. So they learned from the last rover and modified the wheels for Perseverance. But enough about wheels. What in the world is the rover doing there? So the goal of the Perseverance mission is to find rocks that formed in or were altered by environments that maybe could have supported microbial life in the past on Mars. And we want to try to find rocks that are capable of preserving chemical traces of this ancient life if it was ever there to begin with. We don't know if there was ever life there. Um, but we know that the environment was favorable to life. Curiosity has showed us that. We know that liquid water used to exist on the surface of Mars. Spirit and Opportunity showed us that, along with other spacecraft missions. So that's the next step. Did or could Mars have held ancient life in the past? We have no idea if we're actually going to find it. That's the fun part about science. If you go into something knowing what the answer is, well, that's boring. We want to send these spacecraft out to places to answer questions that we don't know the answer to, and even to uncover different information that we didn't even know to ask the question. And so that's the fun part about science. All right. One really neat thing that the Perseverance rover mission also has the ability to do is to auto navigate. The system that it has is called auto nav, and Curiosity does have the ability to do this too, but Perseverance can basically uh, take images and make 3D maps of the terrain in front of it. It can identify its own hazards. It can plan a route around any obstacles with no additional direction from controllers back on Earth. It has the ability to essentially drive itself around. Now, that's not the only way it gets around, but it has that ability. And it also means that it can travel faster if it has a good plan of what's in front of it and how to get around it. All right. But where did it land? Where did we go? Where did we send this thing? Well, this is a not true color picture. This is called Jezreel Crater, and the word Jezero in the Bosnian language means lake. And we think this contains the shoreline of a lake that dried up billions of years ago. Scientists wanted to send a rover here. They wanted to visit this actual shoreline because it may have preserved fossilized evidence of microbial life if it was ever there. In other words, if you're going to find life on Mars, this is likely the place that it could have been. It might not have been there, but this is the likely place to look. The oval that you see in the picture is where the targeted landing area was for Perseverance. The crater itself is a little less than 30 miles wide, and that oval is about 6 miles wide. Again, remember, just let that sink in. On a planet that's 4,000 miles wide, we targeted a spot 6 miles wide. Just let that sink in as to how really amazing that is. So we've zoomed in on this area. The arrow indicates the actual landing site for Perseverance. I added that to the picture. But take a look. You've gotten good at seeing it now. Now you see why the method to my madness, why I was showing you pictures of dried up rivers and especially flowing down sides of craters is because this is why they landed Perseverance here. Was it looks like there was a dried up river here, and it sure looks like a dried up river delta right here. Carved rocks that were carved out potentially by flowing water, and then this area of the crater where a lake may have been. Just to put the library spin on it, the landing site for Perseverance is named for the famed science fiction author Octavia Butler. She has quite a few books that she had written. So if you ever want to look for something that now has a Martian connection, look for the author Octavia Butler. I bet the library would be happy to point you toward resources bearing her name. All right. This is a colorized image of this place on Jezreel Crater. The color has been added to highlight different kinds of minerals in this image of Jezreel Crater. The green color represents, and this is why I told you about it before, carbonate. And again, if you remember, carbonates are especially good at preserving fossilized life evidence on Earth. So we're going to go to a place that there are carbonates there. So if we're going to find that evidence, it would be potentially in this place on Mars, especially where you see that color green. The red, if you're wondering what that is olivine sand eroding out of carbonate containing rocks. So we're looking for minerals we've seen in other places on Mars. Carbonates, olivine, clay, all this stuff. We're looking for also evidence of rocks that were altered by water. We call those sedimentary rocks. Or are we just going to find volcanic rocks? Or are we going to find volcanic rocks that look like the bits were all stuck together by the action of water? So there's a lot of things that we have the opportunity to look for in this place. This is part of Jezreel Crater. This is the crater rim off in the distance, 20 or so miles away. So giving you a sense of the far away look that we've got. This picture I really like because this is a picture from the rover showing you the camera capabilities that this rover has. See how far away that rock is. And 50 centimeters is about, about half a yard, a little bit more than half a yard tall. So that rock is about half a yard in size, and look how far away it is from the rover itself. The rover's cameras, one of the higher resolution cameras, is about a 20 megapixel camera. By comparison, Spirit and Opportunity's cameras were 1 megapixel. You probably have a camera in your phone that corresponds to um, Perseverance's cameras, and some of you may have cameras that are even better than that. But anyway, these cameras are good enough to go to Mars, so that's why they don't put phone cameras on these rovers. Anyway, this is a portion of that river delta. So this portion that we're looking at here is about 30 feet high. Chances are they're not going to drive right up to this one right here, but the goal of this mission is study as many rocks as possible. The rover can drive, move it toward interesting rocks, study them along the way. If we can get close to them, great. If we can get right up to them and study them directly, even better. The team will be mapping out the drive that the rover will be taking to be able to get to as much of this river delta as possible. This is a picture of a hill off in the distance called Santa Cruz. This is about a mile and a half away from the rover, but you can see the crater rim off at the horizon right there. So just to give you a sense of some of the obstacles that they're going to try to avoid. The rover can't just go anywhere it wants. It can drive over rocks that are about 28 or so inches tall, but they try to avoid that as much as possible. They want to avoid big tall rocks, they want to avoid sand dunes. And so they need to be careful along the way so that we don't get the rover into trouble and get it stuck. Just to show you some of the detail that we're seeing in some of these images. This is a natural looking scene on Mars. This is kind of what it would look like to your eyes. But the smallest pebbles that you can see in this picture are only about 1 or 2 millimeters across. If you can see the view on my video, so they're only about yay big. So really, really small. So we've got really great cameras on the rover, 23 of them in all. And these are, again, more rocks that they have been studying. By the way, you're probably noticing I'm not giving you any science results because there really haven't been any. The science mission just started a month or so ago. So there are no science results that have been publicly released yet. I expect those to start coming maybe later on this year. That's when the planetary scientists get together at a few meetings, usually in like the October to December timeframe. So I'll bet you they are going over a bunch of data right now, and they'll probably start releasing some of that information probably a little bit later on this year. So in the meantime, we've got some cool pictures to look at. This set of pictures is from a close-up imager called Watson. Yes, there is a Sherlock on the rover as well, but Watson is a close-up imager, again, to be able to take really close-up images of the rocks. And Sherlock is think of it like a scanner. It can tell you what the rocks are made of by directing certain types of energy at the rocks. So Watson will take the close-up images. Sherlock will start to tell you what those rocks are made of. So again, just showing you what some of the camera capabilities are. We've got this picture taken by one of the navigation cameras. We've got this picture, which is, you can see a close-up of this particular rock right here, which in that picture looks gigantic, right? So that is the zoom camera. And this one is one of those really close-up imaging type cameras. The one really amazing thing about this rover that Curiosity can do is it has a laser mounted on the mast of the rover to be able to zap the rocks from up to about 20 feet away And from the light that comes off the rock, from getting zapped by the laser, they can start to figure out what the rock is made of. So we don't have to be sitting right next to a rock to touch it in order to figure out what it's made of. They can do it from up to 20 feet away. And again, this is a close-up image of one of those rocks. Couple few things and then I'll get to your questions. So if you've got questions, time to put those in the chat. I see that we've got a few in there. So anyway, there is a sundial on the rover. It may seem weird, but this sundial helps the scientists figure out what direction the rover is facing. Perseverance, I mentioned, has 23 cameras. Some of the cameras face quote unquote forward, some a little bit more to the side, some back. So we can see all around, but um, the cameras need to be adjusted remotely to make sure that we're giving the right color information in the cameras. If you ever have seen a camera crew, like a news crew out and about, one of the first things that a news crew camera person will do is they'll white balance their camera. They'll take a piece of paper and they'll stick it in front of the camera lens and make sure that white to white on the paper is actually white through the camera view. And so they'll white balance their camera. That's essentially what this is, making sure that we've got the right colors represented in the camera images. Another is a sundial. And you probably think, well, wait a minute, why can't we just use a compass or GPS or something? Well, there's no GPS on Mars. Those are satellites that orbit Earth in order to give us that information. And there's no magnetic field on Mars. That's what we have here on Earth to make a compass work. So you need something else to be able to tell what direction you're facing. So if you know what time it is and you know what that you can see the shadow, the direction of the shadow on the sundial, you know what direction your rover is facing. This is the set of calibration targets, the circles on the top, the calibration targets for Sherlock. So again, they need to periodically point the instrument at some calibration targets just to make sure it's all the information is standardized. Because over time, an instrument might change a little bit. So you don't want a change in the instrument to mimic false information that you might get from it. So they come back to these calibration targets every now and then. Now, the materials on the bottom are really, really neat. The squares, the 4 squares that you see, are different spacesuit materials. So presumably we will send people to Mars. I have no idea when. For my entire life, it's been, oh, 30 years in the future. Oh, 30 years in the, well, it's still 30 years in the future. But what that means is I have no idea when we're going to send people to Mars. But when we do, they're going to have to wear spacesuits at some point to go walking around on the surface. And so those are 4 different materials that what would potentially be in human spacesuits. So the material on the left square is called Vectran. To its right is orthofabric. The second from the right is Teflon, and the one all the way on the right is coated Teflon. And the material off to the far left, that far circle, that is a piece of clear material called polycarbonate that would potentially be used for spacesuit visors. So the part that the person would look through. And yes, if you're sending instruments called Sherlock and Watson, you're going to pay homage to Sherlock Holmes. And 221B Baker is 221B Baker Street, and that is the address that Sherlock Holmes lived at, had he been a real person, which he wasn't, but that was his address in the Sherlock Holmes books. So again, a little homage to a fictional character. We've got some potential routes that the rover is taking, but the goal will be whatever direction it goes is to get up that river delta as far as possible. What we have is imagery from space that from orbiters that look down and get us some detailed imagery. We've got images from the rovers, or from the rover, sorry, and so that is the ground-based imagery. And we now have the ability to take some kind of intermediate pictures. And that is because we have had such amazing success from this little guy over here on the left. That is Ingenuity. That's a helicopter. And Ingenuity is a helicopter that was sent as a demonstration mission that was just going to fly a handful of times just to see if we could fly a helicopter on Mars. Well, the overwhelming success of that helicopter has meant that instead of the 2 or 3 or 4 flights that they were going to make with it, it has now made 9 flights as of today. And here is a series of pictures that were taken by the helicopter looking down on the surface. This was from a couple months ago. But again, this has been such an amazing success that they are now running the helicopter along with the rover. And this picture was taken by the helicopter. You can see one of its little feet right here and a little foot over there. And it has been scouting out, think of it like a forward scout, scouting out ahead of the rover to find interesting rocks to look at. So we have the imagery from the orbiters from space. We have the imagery from 33 feet up from the helicopter, and we have the imagery from the rover itself. All that will give us the best information to figure out where to drive and what to study. I don't know how many more flights they're going to make. They've already made 5 more than I thought they were going to. So I don't know if they even know how many they're going to make. This has just been an insanely successful demonstration, and now proof positive that we can fly helicopters on other planets. All right, very last thing, and then I'll get to your questions. One of the things that Perseverance will do is not just drill into rocks, but Perseverance is going to core into rocks and actually pull out a piece of rock core sample from the interior of these rocks. And inside the rover body, it has the ability to take those core samples and stuff them into tubes. And then they will seal up the tubes. Again, this is all done by the rover with the mechanics that are inside it. And then eventually, the goal is drop the tubes in one place on Mars so that a future mission yet to be built, yet to be fully designed, will then fly to Mars, land, pick up the tubes, go back into space, get them back to Earth. That will likely involve 3 separate craft in order to do that. Actually, probably, yeah, three separate. One will go to Mars, land, and have some sort of a rover that will go and pick up the tubes. They'll hand them off to that lander that will have some sort of a rocket on it that will take those tubes up to space, where they will then be transferred to an orbiter that's already there, and some portion of that orbiter will then return to Earth. If this goes as thought, then the European Space Agency would partner with NASA in order to do this. So they are packaging up rocks for a mission that doesn't exist yet in the future to be able to study those rocks with the better instruments that we have here on Earth. So why don't we get to some questions?
Yay. Okay. First, I just want to say, yeah, that was awesome. I can't wait to learn
Thanks.
more. Later on in the year, I'm going to keep my eyes and ears peeled, and so I can know if anybody has come up with anything.
Exactly.
But before we get to questions, I just want to remind everyone, I forgot to say this at the beginning. Michelle is going to be back. If you enjoyed tonight's program about Mars, she's going to be here on Monday, November 15th. 6:30 p.m. virtually, and she's going to be talking about Pluto. So I don't have registration open for November programs yet, but it's on the calendar, so you can mark your own calendars. All right, and we do have a bunch of good questions in the chat.
Cool. All right. Here we go. Okay. All right. Mingyi Wang has a great question, and no, Mingyi Wang, this is not a dumb question. It seems over 90% of the atmosphere of Mars is carbon dioxide. Would it have a greenhouse effect? There might be a bit of a greenhouse effect. The problem is the air is so thin that any major greenhouse effect that you might get is offset by the thinness, where you would get some heat being trapped by that atmosphere. There just is not enough air to move all that heat around. So yes, a little bit, but not enough to counteract the thin air. So really good question. I get that one a lot, as a matter of fact. All right, can we tell if the water was salt water like an ocean, or was it fresh water? And the answer is it depends on where we look. In some areas, it appeared that the water was a salty, briny ocean. In some areas, it looks like it was fresh water. It just depends on if you're talking about a river, a lake, a stream, an ocean. So yeah, hot minerally water, salty water, fresh water. We've seen evidence of all of it. And so yeah, there's Mars used to have a lot of water, and usually, and I didn't mention this, but usually there's a lot of people thinking out there. So I bet you if you were thinking this, you're not alone. How in the world, if Mars's air is so thin and it can't hang on to any of that water, how did it have water? Well, we think the air was thicker, and we think Mars was at least a little bit warmer than it is now. So it doesn't have to be really warm. It just has to be a little warmer. And so then we could have that liquid water on the surface of Mars. But then the question is, where did it go? The scientists would love to have the answer to that too. So they're still investigating that. All right. Is it possible that the pictures of rivers on Mars might actually be the result of something like earthquakes that might have created that kind of view? And the answer to that is probably not. If you look at fault lines on Earth, they definitely don't look like that. The other problem is we haven't seen evidence of tectonic faults on Mars. So not like really long, like we see lots of earthquakes at the boundaries of plates, surface crust plates here on Earth. And Mars does not seem to have had crustal plates. It didn't seem to have had a warm enough interior to move those plates around and smash them up against each other and make earthquakes and stuff like that. So that probably didn't happen. And so we would need some other way to make those rivers. And the easier answer is it was actually rivers. So good question. All right. Do any of the rovers have equipment like ground penetrating radar to look for mineral veins beneath the surface? And the Chinese rover, if I'm not mistaken, does have that ability, I think. And someone asked, are the Chinese sharing with NASA in real time any of their findings from the Zhurong rover? Gosh, I hope I said that right, and I apologize if I didn't. In real time, no, but um, the reason for that is that by decree of Congress, NASA is not allowed to cooperate directly with China. We can't spend money together on joint missions or anything, not until someone changes that rule. However, American scientists individually can work with other Chinese scientists. So I'll betcha there's some American scientists, at least tangentially involved with that rover mission. So, and not only that, I would not be surprised if there were results of that rover mission released at the American Geophysical Union fall meeting in December in, where is it this year? New Orleans. Because a bunch of Chinese scientists usually attend that meeting, and so betcha we'll see some science results from that rover. That'd be pretty neat. Um, okay, what kind of data do scientists want to collect with the various spacesuit materials? How long do they last? Does the dust get in and tear them apart? Um, Radiation environment, what does that do to the materials over time? Basically, how long could we expect this material to last in your typical spacesuit that's just kind of out there on the surface? So that's the kind of data that we've got. You figure you got this entire rover, you might as well send some little pieces, maybe this big, because send them along for the ride, get a free science experiment along for the ride. So that kind of wear and tear kind of data is what they're looking for. How far is Mars from other planets? So Earth's orbit to Mars's orbit is about 50 million miles. ish. It can be as little as about 35 to 40 million miles, as much as about 60-ish million miles. Mars's orbit is more oval shaped than Earth's orbit is. And so, depending on where we are and where Mars is around the sun, if Mars is on the opposite side of the sun, it can be over 200 million miles away. So it just depends on where we are at any given time. Jupiter is then at about 500 million miles from the sun. So Earth, about 100 million, a little bit less. Mars, about 150 million, a little bit less. Jupiter, about 500 million, with the asteroid belt in between. So, does NASA have any plans to have Perseverance meet up with the Chinese rover? Wouldn't that just be the ultimate family portrait, right? Unfortunately, no. So the rovers are a few hundred miles apart. There is no way they would last long enough in order to do that. And the goal of the rover missions is not just to drive; it's to collect science information. So if that means less driving, more science, well, that's what they're going to have to do. So we know they would not last hundreds of miles of driving across pretty terrible terrain, I'm sure, along the way. But uh, who knows? Could they land a new one next to the Chinese rover someday? It'd be kind of cool. Um, I don't know if someone has thought of that, but that the Chinese rover has been very successful so far. The imagery in the movies they've released so far has been really neat. I can't wait to see the some of the science results. So that would be great. Hey, more science is more. More is better in this case. So, um, do we know the China rover's mission is also collect rocks? I don't think it has the ability to collect rocks. I think it has the ability to study the rocks, but not to core into them and save them for a future mission. So it's a little bit different science that's being done by that rover. I honestly can't tell you a huge amount about the science mission. Um, sometimes a little hard to get the information about what the specific instruments are. Once we get the science results, that'll be a little easier to tell what some of that is, and it's probably somewhere, and I just don't know. I just haven't looked for it just yet, but I know that the images in the movies are cool, and they are starting their science mission pretty soon. So yeah. Are the rovers staying on Mars, or are they expected to be retrieved? Nope. It's a one-way trip. You go to Mars, you land, you stay. We don't have the ability to bring rovers back. It'll be hard enough to bring those rock samples back, let alone bring an entire rover back. So no, once they go, they go. Um, Kind of like going to the moon. Once you go to the moon, more than likely your stuff stays at the moon. So yeah, it'll it'll be there. Little museum piece in dotted along in various places on the surface of Mars. So, all right. I think I got all the
Yeah,
questions.
you did get all the questions. I didn't see anyone put
Yes.
in Q&A. Thanks everyone for participating in chat. And if there's anybody else who has a final question they want to try and pop in really quick, go ahead. I'm actually going to ask a question that I feel like you kind of already answered in a way. But when I was looking at the pictures and you were describing hills, they might be quite high, but they're not mountains. And so when we think of mountains on Earth, those are created normally through the plate tectonic action. Yeah.
Mm-hmm.
So two plates
Mm-hmm.
meet and pushes one plate up, and that becomes that high peak.
Yep.
So I'm just wondering how those hills were formed, but
Mm-hmm.
also maybe kind of tying this into those other pictures where the rover scraped into the dirt and only a few inches underneath the dirt you find ice.
Yeah.
So I'm thinking, like, is this just like a water planet that had a few hills that were covered by erosion, like over time, wind erosion got those hills, shaved down and down and down until everything was covered?
In a few cases, you'll probably have rivers that carved rock, and so you'll see layers of rock that were eroded by a river. Um, but Mars as far as we know, didn't have the plate tectonics. So no, you're not going to get big giant mountain building. There are big tall volcanoes on Mars,
Oh,
not active as far as we know, but the tallest volcano in the solar system is on Mars. It's called Olympus Mons, but it's a shield volcano, meaning it erupted in the same spot over and over, and it got taller and taller and taller and taller. So that's one way you can make a big mountain, is you've got a big mountain of dried up magma,
yeah.
lava. The hill, the 3-mile tall hill in the center of Gale Crater, Mount Sharp, we thought at one point, how do you get a 3-mile tall hill in a crater? Possibly it could have been wind action.
Mm-hmm.
So wind collecting dust over time, swirling around the crater, may have actually helped to create that hill in some way. Water was probably involved as well, in some way. So you can get hills. I've never seen like what we would call like several 1,000-foot tall mountains.
Right.
But if you are going to have them, it's because they might be short volcanoes, um, or valleys carved by water, or in some way, or possibly the other way around is a deep valley called Valles Marineris. It's think of a 2,000-mile long canyon that's 5 miles deep. That essentially is a big crack in the surface of Mars caused by some sort of geologic action from the interior, caused that rift. Essentially, it's a rift that pulled apart in some
Interesting.
way. So yeah, so you can get deep on Mars. You can get tall if you're a big enough volcano. And there are tiny volcanoes. I just learned this just a few weeks ago. There were tiny volcanoes on Mars too, lots of them. Um, but no lines of them or anything like that, as far as I know.
Okay, well, that's very interesting. And then
Hmm.
we had a final comment. Thank you for an interesting topic. I think we all
Excellent.
agreed this one was really, really interesting. All right,
One of my
so
favorites.
thanks again. We're going to have you back in November for Pluto. So everybody stay tuned for that, and also stay tuned for more information coming out of the science portion of this discovery later on this year, like you said.
Yeah, hopefully so. And if I give this talk next year, it will be different because we'll have hopefully some actual science to share at that point.
Awesome. All right. Well, everyone take care. See you around. And we are recording this. So if you want to watch it again, you can catch it on our YouTube channel.
Good night, everybody.
All right. Bye.